So today learned about base network. Right? Before this class, we had seen the Bayesian classifier. The Bayesian classifier is very simple, but we cannot apply all the problem. Okay. Why we cannot apply? When we learned the Bayesian classifier, at that we have seen all the parameters should be conditionally independent. If there is a dependency, then we cannot use the Bayesian classifier. This is the reason why we cannot apply your Bayesian classifier to all the problems. So now we're moving ahead from Bayesian classifier to Bayesian belief network, or you can say the Bayes network of belief network, right? The Bayesian network basically having, if you are having your data x1, x2, x3, this is your columns which you are using for classification of any problem, right? This all represent node in the Bayes network. Then there are arcs in the Bayesian network. These are the Bayesian component. What exactly the component used to formulate the any graphical models of Bayesian network, right? Then we are having arcs, basically connection between the node. Right. Third major point. Your arc, directed arc, we will see the example about it, and it shows conditional Just a second. Please hold. Please wait for 5 minutes. I had a counseling student. Okay. प्रोसीजर खत्म कर ली थी नीचे रजिस्ट्रेशन ने બધું કરાવી દીધું હા એ બધું થઈ ગયું ફોર્મ ભરવાનું ને બધું થઈ ગયું ઓકે એક કર અરે યાર કોને મોકલો પેલા ઉર્વશી મેમ ને બોલે ઉર્વશી મેડમ આ નંબર સેન્ડ કરને અને પછી બધી વસ્તુ આને સેન્ડ કરતા આને બધું કરીને તમે પેલું એડ કરવાનું તમે લેક્ચર હા હા લઈ લે બીજો ફોટ લઈ લે conditional dependency. If there is the link between the one node to other node, it shows your conditional dependency. One more condition is there. If you are creating any base network, it never include cycle. It means formulating your directed cyclic. Okay. So now we take example. How are we formulating it, right? How exactly we can say that, we can draw it. Okay, if we take example, some of students is coming late in the class, right? We need to find it out, the reason behind it, right? Late for the class. This is one of the, this has been your X1, consider it. So if we talk about that, if somebody is late for the class, it might be late wake up. Right? It might be छोटा छोटा ड्रॉ करना बहुत बड़ा हो जाएगा date of the class late wake up some other scenario which are the other reason the person will get late. Which are the other reason where person get late. एक ट्रैफिक जाम हो सकता है एक रास्ते में कुछ और कंडीशंस हुई एक्सीडेंट्स हुए then there is a jam. You can consider accident one of the parameter. Then maybe the season, if this is being your rainy season because of the rain also you are having season. Just two having dependency for traffic jam. Due to the traffic jam, you having this condition, you are reaching the class late. Even person is seriously late in this condition also, if somebody is having class at 9:20 and is being wake up at after that moment of time, there's been serious reason. Otherwise, if you're on time, you wake up on time, and then also you are reaching late, it might be the condition if you are taking the route, and on that route basically there is certain accidents, and because of that there is a certain traffic jam, and due to that condition also you are reaching late. So that's why I assume this error. Basically, because of the accident, you might be having the traffic jam, and because of the traffic jam, you're reaching late to your class, right? This. And the rainy season, because of the rainy season, you might be stuck having the accidents, and because of the accidents, you are having traffic jam, right? Why I drawn this direct link also, right? Please understand this thing that creating the problem is very important thing. If you're learning the classifier, there's certain procedure for the classifier, and we can understand what exactly you mean by the classification problem. But here you need to understand it. Because of road are wet, you definitely slow down your speed, and because of that, you might be having the traffic jam on the road. It's not only accident can do the traffic jams, any other circumstances are there, the seasonal things are there, roads are not good. This all condition can lead to traffic jam. And because of that, also you can reach late to the class, right? If you talk about this has been for me, if I'm reaching late to the class, this is my condition. Assume that if I wake up late, I might be coming late to the college. If there is accident on road and because of the traffic jam is there, I'm reaching late to the class. I'm not taking a class on time. If there is rainy season, might be because of that you are talking to the some accident condition, and because of that you are having traffic jam and you are late. Even because of the rainy season, your road are wet, and due to that you are having traffic jam and you're reaching late. Beyond that, if I'm taking the lecture labs, in addition to that, I'm doing other works also. We are having meetings and all the things to consider it as at a meeting with some certain official. So if I reaching work at late, it might be affecting my meeting. If I'm reaching to my institution or reaching to my office late, then definitely this gets postponed, right? Or we can say that because I'm late to the class, I need to adjust my all the meetings and all the things. Because if I had a meeting at 9:40 and I'm reaching an institution at 10, so because I will reach the meeting late, and because I'm meeting late, so that's why meeting get postponed. Because I'm late, so the people had postponed the meeting. So this has been your graphical representation of base network, or you can say this is being a belief network. ये और वाला मैंने यहाँ लिखा है और ऊपर ही लिखना था but I don't it. Now when we had learned Bayesian classifier, at that moment we had seen the joint probability distribution problem. Because if you want to calculate the joint probability distribution for all the variable present at that moment of time, then your problem become intractable problem, right? This thing also you need to remember, because we are having many combinations to find it out for joint probability distribution. So for that, we are not solving the joint probability. Now, after creating this graphical model, what we need to find it out? Now we need to calculate CPT, or you can say that local probability distribution, or you can say the CPT means conditional probability table at each node. Okay, we need to calculate conditional probability table for each node. Means here we calculate here, here, here. This all value we need to calculate, right? So now, how many such value we need to calculate? If ideally we are having 1, 2, 3, 4, 5, 6, 7. So 7 nodes in the given example of Bayes network, right? So how much possible values or how much conditional probability table values we need to calculate? This means 2 raised to number of node in this one. If your Bayes network is fully connected, means each and every node is being connected with each other. It's not like that some other, this node is only connected with this, it's not having any parents, it's not having any parent, this. Your arrow will show the relation between your ancestor and descendant. Please understand it. And every time if you are having no parents, it's only having one values. Here you are having traffic jam, you are having two parents. So what condition we are checking for it? Traffic jams, because all the state is having your, this is having boolean state. This simply if you can understand, it's being boolean state. Why I'm telling boolean state? It's only having two state. And if you think about it, means if you talk about that, if you're late or early, it's having two value, 0 and 1. Is there accident on road, it's been 0 and 1. If you are, or if you can rainy day, not a season, then it's been 0 1. Traffic jam, either it's been traffic jam or not, you are late or not late, exactly, meeting is postponed or on time. And if you are there late on, right? So all having binary state. If I want to calculate the CPT over here table, right? This CPT table, what exactly? If I am having traffic jam, what should be my reason? This is true false, this is true false. If there is accident, yes, we considering as accident. Rainy season or rainy day is being, yes. Then we need to calculate what is the chance of the traffic jam. I will write it down exactly. Traffic jam
Sir,
condition over here. Traffic
sir,
jam. Yes.
sir, can you
हेलो.
please start the recording? Can you please start the recording?
कितने मिनट बाद आपने मेरे को ये बोला? ऑलमोस्ट 25 मिनट. कहाँ थे अब तक?
सर यही था, पर अभी उसके पहले आप सर किसी से बात कर रहे थे तो उसलिए नहीं बोला।
मैं किसी से बात नहीं कर रहा था, तो स्टूडेंट काउंसलिंग में आता, उसके बाद मुझे 10 मिनट हो गए। ओके, ये पहले बोलना है, मैंने आपको सबको बताया। स्टार्ट ना, so we need to calculate the conditional probability TP for node traffic jam. Right? So, what are the parents? You are having accident as a parent of traffic jam, and second parent was negative. Right? It's having two values. This is also having two values. So now we need to derive. If there is accident, yes, this is your accident, this is your rainy day. So what is the chance over here? Assume that we are having 0.60%, 60% chance there is mean you are having traffic jam on the road because of this condition. Then you are having your again accident on the road. Zero means there is no rain. That might be certain other probability. Now there is no accident on the road, but there is rain and there is certain probability x1. Now still you don't have accident on the road and there is no rain on the road, then also you are having x2 probability. So this node is having four probability values, right? So if we again go back to it, sorry, this is a four value, right? If we talk how much value we need to calculate or how many probability values we are calculating, the node with don't having any parents, we are calculating only standalone single values for it. But if you are having two parents, the possibility is four. Here you are having two parents, possibility is four. Here you are having two parents, possibility is four. And here you are having one. You total it out, it means 4 plus 4 plus 4, 12, 13, 14, 15, 16. Okay, not 16. It means we are having link from here to here also. If there is a rainy day, it may be chances for the. So it's also having a parent. So it's calculating two value, not a single value over here, right? So total is that 4 plus 4 plus 12, 13, 14, 15, 16, 17. We are calculating 17 probability value in this base network. Before that, I told you that if you see that where I have written 2 raised to n, this is the exactly the values we need to find it out. यहाँ पे हमारे पास नंबर ऑफ नोड्स 7 है, तो 2 raised to 7 minus 1 is mean almost 126, and we are just calculating 17 values. Is there any serious reason why I'm calculating so much less value over here? I told before I returned that condition, if we are having 7 node, the given example, these network header, this is formula, this general formula, if number of node increase or decrease. But if your Bayesian network is having fully connectivity, here we don't have fully connectivity. That's why we are only calculating 17 values. Otherwise, we need to calculate almost 126 values. Right? Now, one thing is very important if you want to understand it. In your Bayes network, we can say that belief network, we are showing the causality. What do you mean by the causality? Any rationalized meaning of it? If you are late to the class, what is the reason for it in this diagram? Either you would wake up late, this is the primary thing, or it might be the accident on the road, it might be the rainy day, or it been traffic jam. All this lead to certain decision, but these are the causes, and it lead to the decision that you are reaching late to the class or not. It's not only the necessary only one thing is there. If you wake up late, then also you might be reaching the class at on time. You manage it out. It's your condition. Sometimes there is accident, then also we are reaching on time. It's not necessary there is accident means there is every time traffic jam on the road, right? So every time it's not that this been evidence is there. If you are drawing the state and certain causes are there, because of that you are leading to the state. But obviously, if this is the direction and we are finding out the probability for it, how much percentage of chances are there? So here we are showing the causality. That's why we are telling. Now, after creating the network, we can see that the graphical representation which we have created. For the base network. Now, next step is to calculate stereo probability. Obviously, here, whenever I had given you the example, this is only one CPT table we demonstrate. If you want to calculate each and every CPT table of this is of traffic jam we had calculated, we calculated over here. Late for the classes. We think about that. Just a second. If you calculate this thing for your late for the classes having two parents, traffic jam and late for the class. This is my node and it's having two parents. One has been wake up late and second is your traffic jam. Right? So this is also having 0 1 value. This is also having 0 1. 0 means you're not wake up late. No, you're not wake up late, and this has been wake up late. This means not a traffic jam. This has been traffic jam. So if we say this has been W and this is T, if there you didn't wake up late and there is traffic jam, so here we are having certain possibility 0.08% chance there is. still you reach late because we are reaching late to the office, right? If still you didn't wake up late and there is no traffic jam, then you might be having this probability to reaching late to the office or class. Now you're using this thing. Now you're seriously wake up late and still there is traffic jam, then you are having 65% chance to reach late to your office. If there is seriously genuine issue and you are wake up late but there is no traffic jam, then there is certain other probability. So this is four value, or we can say that this has been CPT table that you are calculated for this also. So likewise, all the 17 value how we are going to calculate, this is the basic possibilities there. Not randomly. If we are having fully connected Bayesian network, how many connections are there? Please understand this thing. When I told that when we had learn about Bayesian networks, at that moment of time we are having the problem of joint probability distribution, right? And at that moment of time, due to your joint probability distribution and the number of variables are significant, that's why finding out the all probability distribution or joint probability distribution it will be becoming the intractable problem, right? Over here, if you are increasing the number of edges, this is your edges, you're making your Bayesian network complex. Please understand it. It's not like that कि मैं इतनी सारी links बना दूंगा and I can have a great Bayesian network or belief network. You're making your system complex, honestly. Here, in addition to that, here we have taken the Boolean state, or we can say the binary state. Boolean or binary state. I am writing this. Or binary state, right? Because the state can only take two values. But have you think that if you talk about that, if there is a heavy rain, if there is, if we can think about it, or any parameter of this Bayesian network. If we talk about rainy day, it's been severe rain, light rain, heavy rain, we can classify it under that terms also. But here we are not classifying under that term. If you are increasing such type of classification or you are narrow downing the values, means here the binary states are there, means either it's been rain, either it's been not a rain on that day, right? But how much rain has happened, that also we can find it out the cause for the traffic jam. If there is severe rain and because of the rain also there is certain traffic jam, but I just calculating if there is a rain, has been rain for 5 minutes, 2 minutes, it's considered as a rain. And if there is rain for 5 hours, then also it's been considered as a rain. We didn't take any intermediate values for that parameters. And if we are taking such type of parameters, if we are saying, if we are taking some other state, if not a multi-value state, where we are having one means heavy rain, three means heavy rain, two means moderate rain, one means light rain, and zero means no rain. If you are using such type of representation for the state, why I'm emphasizing such type of representation? Because you are making your whatever the graphical representation and the problem very complex, honestly. Though we are losing the information that we are telling we are only taking two states, either zero or one. So in that case, just a second, wait. So if we are having this number of ages more, then also if we write it down over here, ages and be graphical presentation then indicates creating become complex. This also very basic thing that we need to understand. We need to create the model, but we don't need to create a such model which having higher amount of complexity. Please try to understand if we want to bifurcate the seven state in next seven state having all the state having only two values. If I consider that every state having six or seven values, which indicate the CBI means if over here again we coming this has been 0 1 if we are in four values. So what will the impact on CPT table? Then you need to understand it. CPT tables, if we talk about it, this is the table, right? We are calculating the values, conditional probability at each and every node. And if each and every node is having more than two values, now imagine the size of the CPT table. And we are calculating the conditional probability table or local probability distribution at each and every node. Even we are having seven nodes to find it out why I'm late. In addition to that, I'm increasing the values for number of state. It's not binary value. Now you are having multiple values for that state. If you are late, then also if you are late by 1 hour, late by 3 hours, late by 6 hours, late by 8 or 9 hours, or more than 6 hours. If I want to classify, I can classify like this also. But it creating the unnecessary computation burden on the system. Please try to understand it. It's important we need to find out if you are late or not. How much late, we don't need to quantify that thing. If we need to quantify that how much percent is being late, if there is certain amount of flexibility is there in the system where we need to calculate the number of hours you have spent to the institution, then you should do. But when you are coming to the class, if you are late by 10 minutes, then also you are late. If you are late after coming, you are coming after 40 minutes, then also it's been late for me. Because at the end, I need to take decision, I need to give you the attendance or not. So for me, 5 minutes, 10 minutes, 15 minutes, or 40 minutes, everything considered as a late. Because you come after your class has been started. So we don't need to classify that कि 15-10 मिनट लेट था, एक 20 मिनट लेट था, एक 40 मिनट लेट. But for all the three of the reason, we can put in one simple node that means in the late category. We don't need to unnecessarily jump to that decision now. We just need to calculate okay how much time it had spent. Okay. So why we are not getting 2 raised to this 2 raised to number of nodes in your base network. This problem we are design, right? So you might be designing some other problem where you are having 15, 20, 30 nodes also. I don't care about it. But you need to think about it. This node is like your parameters x1, x2, x3, x4. When you're using your Bayesian classifier, at that moment of time, number of columns are your features, right? For classifying any such problem, if you are giving loan to the customer, if you are having some disease classification problem or leaf classification problem, you are having number of features. With this, your number of columns. This basically causing certain condition where you can come to the decision that this customer get the loan or not, or this plant having this disease or not. These are certain causality that we are representing in our Bayesian belief network. Okay. Okay. Thank you. We'll meet in next class.